Team A15 is back to talk to you about conditional probability and independence. I'm Zach Kendall, along with Ben Schlanger, Marissa Lamberty, and Sean Prodden. All right, let's get started. Conditional probability is the probability that the event E occurs given that the event F occurs. This is denoted as the equation following. The intersection of E and F is the probability of both events E and F occurring. P of F is the probability that an event F will occur. Note that according to this equation, P of F cannot equal 0. It must be P of F is greater than 0. Let's try an example. In a group of people, 49% listen to folk music and 33% listen to both electronic music and folk. What is the probability that a person listens to electronic music given that they like folk music? Let's let event E equal person that listens to electronic music, and event F equal the person that listens to folk music. So the conditional probability is going to be the intersection of E and F over P of F. While P of F is the probability that a person listens to folk, P of F is going to equal 49 over 100. The intersection of both events is the probability that a person listens to both electronic and folk. Therefore, the intersection is 33 over 100. So, plugging that back into the equation, 33 over 100 all over 49 over 100 gives you 33 over 49, which is 0.673. Let's try another example. What is the probability of getting a sum of 5 when 2 fair dice are rolled, given that at least one of the die shows a 2? Well, let's break this down into two events again. Letting event F equal the sum of 2 fair dice is 5. Letting event T, at least one of the dice shows a 2. So as you'll see, plugging that back into the conditional probability equation, the intersection of both events is going to give us the probability of having 2 rolled fair die add up to 5 with at least one of them being a 2. The intersection of both events is going to be 2 over 36, that being the 2 points 2, 3, and 3, 2. The P of F is the probability of rolling at least 1, 2. P of F is going to be equal to 11 over 36. And these are all the possible combinations below. As you can see, carrying out the equation, we're going to end up with 0.182. Let's talk about independence. Two events are independent if the occurrence of one event has no effect and gives no information on the probability of the other event occurring. In other words, the probability of an event E occurring is the same as the probability of E occurring given event F occurs. Two events, E and F, are pairwise independent if the probability of E and F equals P of E. Let's try an example dealing with independence. Let E and F be the events that a family of n children has children of both sexes and has at most one boy respectively. Are E and F independent if n is equal to 2, n is equal to 3, and n is equal to 4? The answer is no, yes, and no. Let's try to remember that the intersection of E and F must be equal to the product of the probability of E and the probability of F. Let's talk about pairwise independence. A set of events are pairwise independent if every possible pair of events are independent. In math speak, the events E sub 1 and E sub 2 are pairwise independent if and only if the intersection of the probability of EI and EJ are equal to the probability of EI and the probability of EJ for all pairs of integers I and J, with 1 less than or equal to I, less than J, less than or equal to N. Now let's discuss mutual independence. A set of events are mutually independent if the joint probability that they occur is equal to the product of the probabilities of the individual events. A further explanation is right below. And remember to take note, if a set of events are pairwise independent, it is not always also mutually independent. Pairwise and mutual independence example continue. A number between will be random chosen between 1 and 20. Let event A equal the number is even. P of A is equal to 10 over 20, which equals 1/2. Let event B be equal to the number that is divisible by 3. P of B equals 6 over 20, which is 3 over 10. Let event C equal the number is greater than 10. So the probability of C is equal to 10 over 20, which is 1/2. Now the intersection of A, B, and C is going to be 2 over 20 or 1/10. And the product of the probability of each event is going to equal 3 over 40 at the end. Now you can see that because they're not equal, it is not mutually independent. Okay, now let's check for pairwise independence. We go through and check through A and B. We see that they're independent. We check B and see that they're independent. So therefore, A and C are independent. Remember the note we said that just because something is mutually independent doesn't mean it's pairwise independent, and vice versa. So therefore, all threes are independent. Therefore, the entire thing is pairwise independent. Remember to visit our website for more information on conditional probability and independence, as well as other discrete mathematics subjects. Once again, this is Team A15, EX203 Discrete Math at the University of Michigan. Before we go, I heard this rumor about lumberjacks. I heard they make good musicians. It must be their natural logarithms. Oh!